I want to review the quiz from the 5th of September. It actually has the wrong date on it. It is the 5th of September, but it's 2014. And unlike a lot of other reviews for quizzes that I do, when I go over the versions of the quiz, I'm going to go over both at the same time. And the reason I'm going to do that is because the data sets on both versions of the quiz were identical with one exception. So we're going to do both at the same time. So here was the distinguishing characteristic between the two quizzes. Take a look at number 5, and if you're following along on this video, take a look at 5 and you can see what state you're in. One of them is South Carolina and one of them is West Virginia. So I'm going to go in this video back and forth between South Carolina and West Virginia. So depending on which one you had, you can keep an ear open. However, a lot of what I'm going to say is going to overlap in between the two. In other words, number 1, 2, and 3 are the same for both South Carolina and West Virginia. So let's get started. Here we go. Number 1, for both versions of the quiz, the alpha. Alpha is the first letter of the Greek alphabet. Alpha graph is, most people got this right, but let's do it anyway. That one is exponential because it's the shape of an exponential graph. We are multiplying by the same thing to go from one to the next. That actually is geometric. Also, beta graph is clearly linear, and this one is quadratic. I will take this opportunity just to say something else that's kind of important. Exponential can also go down. This is called exponential decay. Kind of looks like that. Levels off somewhat down there. You know this, but linear graphs can also go down, and this could be upside down, or it could be just half of one of those. Okay, so here we go. The data set for both South Carolina and West Virginia versions of the quiz were the same for this, and I'm going to go through this somewhat quickly because you know these steps. You have that little yellow half piece of paper that gives you all the steps, but let's go through it anyway. You start by, first of all, figuring out what X is and what Y is, and it's already in there for you, and that's going to come in handy. So, stat, we need to press enter on edit. If you have stuff in there, clear it out. Go up to the top and clear and enter. Do not press delete. It complicates your life. By the way, I'll take this opportunity to tell you, if you do press delete, boom, L1 is gone. How do you get it back? You have to insert it. So just in case that ever happens, I'm showing you now. Second and insert is the INS button right there. And then you see the little L1? You can hit second and L1 and it brings it back. Okay, there we go. Now you know. And so we'll type X's here, Y's there, and L2. So let's do that really quickly. 35.2, 41.9. You may want to fast forward through this part of the video unless you're completely following along. And obviously I'm not doing it right because I was looking at the numbers and didn't realize where I was typing them. Oh well, one more reason to fast forward through this part of the video. Alright, let's try this again. That wasted 30 seconds of your life you'll never get back. But I'm not starting this video over. I ain't doing take 2. We'll get this thing done. There we go. Now I will say this too. If you type even one little number wrong, it's going to mess up your answer. So don't. So make sure you're right. So before we move on, I am going to look through here and just kind of proofread, make sure we're on the right track, make sure I haven't typed in any numbers incorrectly. And there we go. 78. Looking at both sets. Okay, everything is correct. We need to turn our scatter plot on. Notice where it says stat plot up here, second stat plot. Everything is off right now. We're going to turn it on. It will remain on for the remainder of the quiz, so we don't have to do this step again. We want to look at it and see what shape it is. So we press zoom and go to number 9. That looks sort of kind of linear to me, somewhat. By the way, if you have something in y equals, if you have a random line or a curve going over there, you can get y equals and clear it out. There we go. Hit graph again. That is linear. And it said so. Number 4. What is the linear equation of the regression that best fits these data? Data is plural. That's why it says these data, by the way. Stat. You want to calculate your linear regression. And I think most of you are okay with the steps. It's just a matter of knowing how to do this stuff down here. So let's keep going. Just in case we need it later, we are going to press vars. This is not on your yellow sheet, but it will be next semester, which won't benefit you, will it? Press vars. Go to yvars. Enter on function. and enter on y1. Now it's in there if we need it. We're going to write that down. So what is the linear equation of the regression that best fits these data? Y equals, oops, wrong color, not that it matters. Y equals ax plus b, that's linear, it's like mx plus b, so negative 1.32 rounding to 2 decimal places. X, that goes in the place of a, plus 130.53. Okay? Alright, let's read number 5 and then we'll switch to the other version and do the one with West Virginia. Charleston, South Carolina lies at a latitude of 32.8 degrees north. What can you expect its average temperature to be? Some people said 32.8 degrees and they found it in the chart and they were like, oh, 90. Yeah, that's what Dallas is, but we're going to look at the trend itself. So even though it has a matching number over here, that number might be an anomaly, and so we need to figure out what happens at 32.8. Here's two ways of doing it. We can either go negative 1.32 times 32.8 plus 130.53, and that will give us an answer that will be reasonable. Or, since we have stored it under y1, we can go to the table and figure out what happens at 32.8 degrees north. Now, we know this is an x value because it says latitude. I just want to point that out. This guy right here, that is an x value. It says, I'm giving you an x, now tell me what y is, because temperature is y. No, drop the pen there. Okay. So if we go to table set, second and table set, and we set the independent to ask, there, get that where you can see it a little bit, set that to ask. Now we can go to the table, second and table, type in whatever we want, and we want 32.8, and it gave us that temperature. We'll round it to 2 decimal places just for fun. And we have 87.35 degrees Fahrenheit. I would accept 87. Now, if we went this route originally, we might get something that's a little bit different, but not too drastically different. 2 times 32.8 plus 130.53. Nope, not too far off. 87 and some change, so it's still close enough. It's still pretty much the same thing. Okay, number 5 again. Okay, we're going to switch to West Virginia. Up to this point, everything has been the same. So if you're like, what about 1 through 4? Exactly the same. Exactly the same. West Virginia lies at a latitude of 38.3. You won't find that one in the chart, just saying. So what we need to do is exactly what we did. Go to the table, type in 38.3, boom, there you go, 80.11 degrees Fahrenheit. 80.11 degrees Fahrenheit. Same procedure. Okay. I'm going to switch back to South Carolina because that's where all my work is. Again, if you're West Virginia, it's the same thing, unless I say otherwise. Which actually number 7 is different. We'll do both of those. What does the slope represent in this situation? And I mentioned this in class, but this is wordy. But here it goes. It's y per x. And now we have to take this garbage and make it good plain English. Y is the average September temperature. So I'm just going to say it's the average September, I'll abbreviate that, temperature per, now we're tempted to put latitude. So before we write the word latitude, we have to know that this is a unit. It's 1. So it's per degree of latitude. Okay, now this is measured in Fahrenheit. So I'm going to squeeze something in. This might drive you crazy if you want to use a little caret key here. But I'm going to say that's degrees Fahrenheit per degree of latitude. It's the average September temperature and how it affects the degrees Fahrenheit per every degree of latitude. And just because I feel like it, here's the Earth. There's your latitude. There's your equator, the big bold one in the middle. And so what they're saying is the latitude that you have, if I'm here, it's going to affect my temperature. If I'm here, it's going to be a little colder. If I'm here, it's going to be even colder. Closer I am to the equator, yeah, hotter it's going to be. Everything here is in the northern hemisphere. Number 7. At what latitude could you expect, let's pause that right there. At what latitude? Is it asking you for X or Y? It's asking you for the latitude, which is X. Can you expect a city that has an average September temperature? Oh, they're about to give you Y. Right there. They basically said, I'm going to give you a Y. Tell me what X is. We have the equation to do it. So Y equals, I'm going to write it all one more time, 1.32X plus 130.53. And we're going to plug in the Y they gave us and crank out an X using our fantastic solving techniques that we've been using. Here we go. Oops, we're at the wrong number. That should be 53. Kind of hard to salvage that, isn't it? It's a mess. All right, let's slide this thing up. Here we go. We're going to subtract 130. Boy, I'm having a hard time, aren't I? Subtract 130, 53. Cancel those out. Subtract 130, 53. $60 minus 130, 53 is negative 70, 53. Negative 70.53 equals negative 1.32x. We will now divide by negative 1.32. When I hit enter, it's going to tell us the latitude at which we could expect that temperature. Boom. About 53.43, give or take a few decimals. We're not going to be too picky. 53.43 degrees north. Don't put degrees Fahrenheit. This is latitude. Well, Mr. Reader, that's great. What if I have the other quiz? It's the same procedure. I'm going to go through that very quickly. All right, here we go. Exact same formula. Y equals negative 1.32x plus 130.53. We're going to put 55 in for Y. So 55 goes here. I'm going to do this one in my calculator, and I really hope you're not offended by that. Here goes. If I was going to solve it, I would subtract that, then divide by that. So let's do it. 55 minus 130, 53. Boom. Divide by negative 1.32. Boom. We just found it. 57.22 degrees north. All right. That was the West Virginia quiz. Let's flip it over. Okay. On both versions of the quiz, this problem was the same on the back, which means number 8 was the same, number 9 was different, and number 10 was the same. Okay, so let's just do one of them. Hospital has prepared 100 milligrams of radioactive isotope for a scanner. It's radioactive, it decays quickly, and the chart shows the amount remaining after it was prepared. And they said it was exponential, so yeah. Let me say something here before we even get into it. These numbers are decreasing, it's exponential, so I know it's going to look like, it's going to go down. It's going to be exponential decay. Let's hit stat. Enter on edit and type some numbers in. 0, 1, 3, 6, 8, 12, 20, 30, 40, and, oh wow, that worked out well. Okay, go to L2 and type them in. 100, 89.09, 70.711, 50, 39, 685, 25, 9.921, 3.125.984. Done. I'm going to double check real quick, make sure we're on the right track. Even one number wrong throws the whole thing off. There we go. We're good to go. Here goes. Let's clear that out. Now, we can turn our scatter plot on if we wanted, but it's already on. See? Told you. Zoom 9. Told you. Told you it looked like that. Mr. Reader, what's that? That's left over from the last problem. I don't like him either. Let's kill him. Y equals, delete it. Hit clear. Alright, we stare at it and we say, sure enough, it is exponential. So we're going to answer number 8 now. What is the exponential equation that represents this? So we hit stat and go over to calc. In case you don't remember, it's 0, but you can scroll down and you'll find him. He's expreg. Hit enter. Now, we would like to save him in our calculator under y1, so we hit vars and go to yvars. Hit enter on function and y1. There we go. The reason I save it in there is because it's more accurate. So 100, I want you to notice it's a times b to the x. It's a completely different format. Some people, when they wrote their quiz, wrote it down like it was linear, and they were like ax plus b. No. It's a times, and we'll put it in parentheses, b, which is 0.89 rounded off, to the x. That's what it looks like. And it's saved in y1. How many milligrams remained after 24 hours? Shoot, I don't know, but let's kind of translate that. How many milligrams? Whoa, Mr. Reader, what's it asking? It says find y when I give you x. Two ways of doing it. You can do it on the paper, or you can go to the table and type in 24. Let's delete those that are left over and type a 24. And you'll get 6.25. 6.25 milligrams. Now, if you did it in the calculator without the table, and you did 100 times 0.89 to the 24, you'll have an answer that's a little bit different. And here's the reason why. This is 6.1. See, notice the way the equation really is. Notice all those decimals. That matters. But we rounded it off. So actually, this one is more accurate than that one. Okay, let's go to the other quiz. If you have the West Virginia quiz, let's do number 9 real quickly. Same idea, only it's 36 hours. I'm going to give you both answers real quick. If we do 36, we get 1.56 milligrams. Or we can do this, and it's 1.51. 1.51 milligrams. Either one of those is the same. They're not the same, but they're an appropriate answer. Okay, so that's West Virginia right there. I'll leave that on the screen for just a minute. I'm going to go back to South Carolina and keep working. All right, number 10 is the same on both quizzes. This graph is clearly decreasing. How is it shown in the equation? What I wanted you to tell me on this was, where can I look in this equation and say, man, this thing is decreasing, and here's why. Okay, let me give you the nuts and bolts of exponential equations. This is your y-intercept. It's your starting point, and it makes sense because we started with 100. Now, the equation was a little wacky, and it had some crazy decimals in it, see? So it wasn't exactly 100 based on the data and the way things rounded in the process of calculating it, but it's pretty much 100. This is the growth or decay, I'll put that in there, factor. In other words, for every hour, slide that out of the way here, for every hour that passes, we're going to keep 89% of it. Well, if I'm keeping 89% of something, then I got rid of 11%. If I'm only going to keep 89, then I'm getting rid of, well, if I'm getting rid of, it's going away. So the graph is decreasing. How is it shown in the equation? Let me write it out in good plain English. The B value is less than 1. If the B value would have been greater than 1, if this would have been 1.24, then it would have been increasing. Okay? All right, I'm still on the South Carolina quiz. And this is a really interesting thing. If you want to read it, it'll change your life. It really is interesting, very historically interesting. The Middle Ages were a great time for scientific discovery. But that's not what we're here to talk about now, was it? We're going to do this one because the West Virginia and South Carolina quizzes are different. These tables are different on these. Notice they start the same, but some of the numbers are different. So right now I'm on South Carolina. So here goes. South Carolina, I'm going to do 11 and 12. 0.51, 1.523, delete everything else. There we go. Come up here and clear. Oops. Clear, go down. All right. 5586, 6131, 6186, 5751, 4826, and 1506. And there we go. Make sure everything is in there right. And it is. Yeah, it is. Okay, we're good to go. So it said it was quadratic, but let's look at it anyway. Again, scatter plot's already on. We've already done it. We don't have to deal with it. Zoom, 9. Whoa, that looks quadratic to me. Kind of comes up and down and over, that kind of thing. So we know it's quadratic. we hit stat. We want to calculate the quadratic regression. If you press vars and go to y-vars and function and enter on y1 and you hit enter, not only do you have an equation, it is saved under y1, which will be very convenient. So y equals a x squared plus b x plus c. There we go. That looks like fun. Okay, let's read number 12 real quickly. How far was the ball above the ground? Let's pause. Rephrase. What was the height of the ball? Rephrase again. Find the height. Find y. When 2.5 seconds, that's time. When x is 2.5. Find y when x is 2.5. That's really what that question said. So let's do it. We already have it in the calculator, so you can hit second and table and put 2.5. Done. 3411. 34.11 meters. Now, you could type it in for x if you wanted. Negative 9.8 times 2.5 squared. That's what makes it quadratic. Plus 15.8 times 2.5 plus 5586. You get the same thing. Okay, that was South Carolina. Real quickly, let's go to West Virginia. If you need to see it again, or if you're seeing this for the first time because you were waiting for West Virginia. Here we go. Stat, edit. Those numbers are the same. These numbers are not. 5901, 5726. Same procedure, so I'm going to go very quickly. There we go. Everything's in there. Everything is right. It is quadratic because they said so. Stat, and it's quadratic because it's a falling body. Not literally a body, but you know what I mean. We're throwing something and it follows a quadratic pattern, just so you know. Quad, y-vars. There we go. Negative 9.8. Same leading coefficient. The reason for that is that's the constant, the gravitational constant on Earth. Just in case you ever wanted to know that. Really interesting stuff. Physics is fascinating. That's 5586. 5586 was one of the two constants in here between the two equations. 2.5 seconds. Same thing. Go to the table. 2.5's already in there, so it changed this automatically. So it's 22.61 meters. There we go. That was West Virginia.